everybody for joining us. My name is Lynn. I am a customer service rep here at WarmlyYours, and today I am joined by the wonderful.
Well, they couldn't make it, but this is Scott. Hi, everybody.
Awesome. Hey, so we're going to be talking today about some of the benefits of electric floor heating for the home. And if you have any questions during today's webinar, please don't hesitate to ask. You can type them in the webinar chat and we'll see them. If we don't see them right away, we'll definitely get to them by the end of the presentation. So today we're going to be going over kind of a brief introduction to electric floor heating, really what it is and how it works. We're going to talk about, and then we're going to talk about some of the benefits of it. So we're going to talk about the comfort that can be gotten from floor heating. We're going to talk about the energy efficiency of the systems, as well as how they can make for a healthier home. And then at the end, we're going to talk about how simple and easy the installation can be. So floor heating is pretty much either hydronic or electric, and everything we offer here at WarmlyYours is electrical based. So Scott, can you kind of tell us, what the difference is and how our systems work?
Well, yeah, a lot of people, when you mention floor heat, automatically assume it's hot water just because that's what they were doing in the 50s and the 60s. We are doing that same thing with electricity. And what we're doing is we're actually, the electric that's going through the cables buried in your floor is actually a radiant heat, and it actually warms up objects and people inside of a room, and not necessarily so much the air. The air eventually gets warm, but what happens first is you will feel warm. Even if the room temperature, the air temperature is 65, you can still feel very warm because that floor heating is actually warming you. So that's what's so good about floor heating. It also is great in basements. We're going to talk about that a little bit later, because basements tend to have cold floors. If you have a basement, and or if you live on a concrete slab, tend to have cold feet. So what this does is it eliminates that heat, eliminates that chill from the floor, and also generates heat to warm you and your feet, and a very easy to install way. So that's very, very important to keep in mind, that if you're doing a renovation in your house and you don't have a boiler already, then it's much better to do electric, because then you don't have to install a boiler. You don't have to add 2 or 3 inches of floor depth or height to get hot water tubes in and that sort of thing. So it's a great DIY friendly thing too. It's not rocket science, which sometimes hot water can be, because you have to worry about pumps and the water and the other stuff that goes along with that. So that's exactly what floor heating is. It warms the room. It warms the occupants of the room from the floor level. You don't have any hot air.
Yeah, and definitely that is a big difference. And you can actually really see that in this picture. I like that you can really get an idea of how that radiant heat actually just radiates through the space, instead of that forced air, where it's really warm air just kind of being pushed into a room and, kind of warming as much of the space as it can.
Right. You're not in that vortex of hot air. Then it cools off, comes down, and makes your feet cold on its way back to the cold air return. Then it does the exact same thing. So if you're in a basement and you don't have a door to your basement, all that heat that blows down and then goes right back up also then goes into the second floor, and it doesn't stay down in the lower floor. So that's a good way to keep the heat in the space, and the heat actually is warmer where you want it to be, down by where you are, not up at the top of a room where the hot air is trapped. So the electric floor heating cable, you need one thing to remember about that is the heat radiates about 1.5 inches from the cable itself. So that's why most of our mats are spaced at 3-inch spacing, because that allows perfect uniform heating under the floor. And that's why you have such a nice warm coverage. But that's also another reason why you can't just put a strip of floor heating down the middle of the room and expect it to be warm on the floor in 2 feet or 3 feet on either side. You have to, the area that has heating cable under it will be warm, and the areas that don't have the heating cable will not be warm. So that's one important thing to think about when you're laying it out. You don't want cold spots in the middle of your room. So where there is no cable, there will be no heat in the floor there. So that's one thing you really, really want to watch out for.
Yes, absolutely. And kind of, we touched on it a little bit, but it does give a lot of comfort. It's going to give you heat, like you said, where you'll feel it the most. So obviously, if there's heat that's kind of collecting near the ceiling, you're not going to really feel that. But if it's warm against your feet, if it's warm, kind of radiating up, heating the objects and yourself in that space, it's going to give you that really natural warming feeling. And this is especially important if you have a room with very high ceilings. Obviously, heat rises, so the higher the ceilings, the farther away that heat is going to end up from you with a forced air system. So these are really good for rooms with high ceilings, as well as pretty much any other space that you'd like to warm up.
Yeah, and just keep in mind that heat loss is your enemy. The more windows, the more exterior walls, the more skylights, the more fireplaces, all of those things lose heat. They're heat loss subjects. So you need to watch out for those. Also, when you're thinking about putting floor heating down, you never put the floor heating under a permanent fixture or under a cabinet, but you can put the heating wire in the toe kick of the cabinet, but you never ever install it under the cabinet. Now take a look at the drawing or the picture here. You can actually see this is a tub up on legs. We would not put the heat under that tub because there's a pretty good chance if you look at that leg, it's probably bolted. There's a possibility that it's bolted to the floor, and you don't run bolts through electric floor heating. That's a bad combination because running a bolt through the electric wire can damage it. So we would stay out from under that tub because it's a permanent fixture. It's sitting there on legs, but you're never going to move it. And you wouldn't go under that cabinet there in front, but you would definitely go in the toe kick area in front of it because that's where you stand. When you're standing in the bathroom, most of the time you spend, except for me, I try not to look in the mirror, but a lot of people want to look in the mirror to see how they look before they go out. Your feet are going to be right in front of that cabinet. Your toes are going to be right in the toe kick. You want to make sure that you have the floor heating there.
Yes, absolutely. And we kind of talked about this as well. Basements obviously are known to be difficult to heat. Usually, if you think of a basement, even a finished basement, you often will think of it as being a cold space, often a little bit humid, and just really difficult to keep warm. So when you're adding heat to that space, it's going to give you a lot more comfortable, it's going to make that basement more comfortable year round, really.
And it's not only for basements, because a lot of people watching this today probably don't have basements. It's a Midwest thing primarily. But we love basements, but also it can be the same for a first floor. So the thing is, if you have vents blowing hot air down, that hot air goes down about 2/3 of the way, then goes right back up to the ceiling. So it's always going to be cold down near the floor. There's nothing holding the hot air down there. So that's what's so good about electric floor heating is the heat starts there and it warms the entire space. So you're actually in the heated space instead of having hot air hitting you in the head and then going right back up to the ceiling or upstairs. So very, very good heating solution for lower levels and basements.
Right. And then kind of talking a little bit about the energy efficiency, I think that there's kind of a common misconception that this is heating with electric in any way is very expensive. And that's really not generally true. Generally, floor heating is very energy efficient and it doesn't cost much to run each day. So can you kind of tell us, Scott, how you'd be able to kind of figure out what the operating cost would be?
Well, we have a free tool that we're going to click on here in a second. But before we do that, keep in mind that one good thing about this electric floor heating is you can put it in different rooms at different temperatures and to come on at different times, which means if you're heating the floor in your living room, you don't have to heat your whole house just to stay warm while you're sitting in the living room. So what you do is you set your temperature down 5 degrees. So you, instead of 68, you set it to 65, 63, something like that. And then if you're in the living room, you turn the living room floor heat on, then you're warm in the living room. Then when you go to bed, you turn the power on the heat in your bedroom and it heats that space and the rest of the house stays at that lower temperature. You're just heating the area that you're in at the time. There's no need to heat a whole house when no one uses that spare bedroom except twice a year, when no one goes to the basement more than once or twice a year for the holidays. So why heat them when you can do it with electric floor heating and zone it that way. That's what's so great about the system, because we always suggest that you put a thermostat in each space so you can control it individually, because that way I'm going to be in this room I'm in the bathroom every day at 6:30 a.m. to get ready to go to work. I'm going to turn the heat on in there, and I'm not going to be in the living room. I'm not going to be in the basement. I'm not going to be in the spare room. There's no need to turn heat on there. So that's how you can run your thermostat at a lower temperature and save you money all the way around. So the money that you may incur operating the floor usually is netted out by you turning the heat down in the rest of the house. So a lot of times it's simply a push. So we're not even going to talk about that. We're just talking about what it costs here. So let's take a look at this free tool that's on our website, and you can get an idea of what is going on there. And there's a lot of
Great. So
different
this
things to
is
play with here too, which is cool.
There are. So I definitely recommend checking this out. Our website is, of course, WarmlyYours.com. And you can actually find this under the resources tab under tools. If you go to running cost calculator, this is where you're going to find it for floor heating. And we also offer one for snow melting. So Scott, can you kind of walk us through how to use this?
Yeah, it's got a bunch of different things. So scroll down there, you can see we're choosing what we're using to heat. We're choosing the room size. We have the energy rates built in by your zip code. And then what you can change is the daily usage slider there. And that's going to affect your cost. So the bigger the room, the more electricity it's going to take. The smaller the room, the less it takes. So it kind of gives you an idea there. So let's go up there. We can just take a quick look. Temp zone floor heating system, that's what's used in bathrooms with tile and such. So we can leave that there. We can choose that. We can choose bathroom. Or if we wanted to, we could put square footage over there if we wanted, but we're keeping it simple. So the bathroom, and then put in energy rate of 901. What was the TV show?
90210.
Yeah, there you go.
Believe me, I know 90210.
That's California. Now go to 60047. Wow. That can impact your floor heating costs, right? So just by the difference of your zip code, you can see it costs different amounts in different areas. So it lets you get what your rate is, so you know exactly what you're up against. Now
Yes,
let's
and I
say
think one
that,
of the big things with the sliding tool is really being able to see what it will cost for different amounts of time, because obviously that I think for most people will vary throughout the year. In the winter, you might be running it 24 hours, and maybe you think, oh, I'm not going to run it, 24 hours, but maybe you would in the winter, and then in the summer, you're only running it for 5 hours a day. So there is a lot of, wiggle room to consider there.
yeah, but most people would not have. I've personally never talked to anybody that's had it on for 24 hours, because that's
I
what they
think I
use to
did in
program.
Alaska.
Oh, yeah, yeah. But most of the time you're using a programmable thermostat, right? So the programmable thermostat lets you choose how much time you want to, like if you're in the house from 6 to 7 a.m. And then you go to work and you come back and you're home from 5 until 9. So there you have just a few hours. You don't have 24 hours. There's no need to heat it while you're not there. So that slider makes a big difference there. So it's a pretty interesting tool.
Yeah, it's definitely very helpful. And I would recommend it, when you're kind of starting at least to plan out your system, you'll have a good idea of what you'll be looking at per day, per month, and per year.
Can you go back to the slide on the side there? When we first came to this page, I just want everybody to see the tools that are there besides this one. Yeah, the resources. So you can see there's the online design tool, build a quote. You can find an existing quote if you have one in, running cost calculator, floor heating heat loss calculator. That's especially helpful for people that are interested in using electric floor heat as the sole source of heat. We can tell you
Yes,
how many BTUs your particular room needs, and if the electric floor heating system will supply that number of BTUs. So that's very good. So thank you.
absolutely. So back here. And Scott, you kind of touched on this, but the programmable controls, I think, are really going to be what truly helps keep that operating cost really low. If you're not running it constantly, if you're not running it all day, every day, like you would with forced air, it's obviously going to make a huge difference in cost.
Yeah, and I saw what you did there by saying touched on, because that is a touch thermostat you have there. So yeah, that's it's important to know whether your floor can have a programmable thermostat or not, because some hardwood floors don't let you set back the temperature. Some carpet floors don't let you set back. They'll say you must keep this flooring at the same temperature 24/7. Maximum deviation 1 or 2 degrees. Well, if that's the case, you don't want to use a programmable thermostat because you can't set it any lower and you can't set it any higher. You just have to keep it where it is. So first of all, find out if the floor you're using, tile is a perfect example. You can use a programmable thermostat for that. And that way you can have different varying amounts of heat throughout the day, and that'll save you some operating costs.
Absolutely. And this is a pretty responsive system, which is why we're able to recommend, turning it on and off kind of as needed. Can you kind of compare this, Scott, to hydronic and how responsive that is?
Oh, hydronic is it's full of overshooting and undershooting, which means it will, if you set the temperature at 80 degrees, it'll say, okay, we need to heat. A lot of hydronic systems don't even have sensors that go on the floor. They're just all based on BTUs and that sort of stuff. So that if you say I've got a maximum floor temperature of 80, that control has no idea what the maximum floor temperature is. It's just sending hot water through until the air temperature increases. So that's a main difference between hot water and electric, is that if you have a hardwood floor or LVT or laminate or something that has a maximum temperature limit, this is a much better match for you, because we'll get if it needs to be 80 degrees, we'll go up to 80 degrees and it'll stay there. There's no overshooting or undershooting, because the temperature at the beginning of the cable is the same temperature as it is at the end. With hot water, the hot water comes in hot and it exits cold. So you could have a doorway where your tubes come in, that doorway could get really hot. And then as it works its way through the room and comes back out, that other area could be really much cooler. So electric is a much better system for, it eliminates overshooting and undershooting. That seesaw up and down temperature starts out hot, then it cools off. This goes to the temperature and it stays there. And it will also keep track of that maximum floor temperature, so it never goes over. So that's very, very important if you have one of those floors.
Yes, absolutely. And when floor heating event, as we usually call them, is scheduled, then it's going to start warming up before it actually says, so that it's at that temperature at the time it's set for, correct?
Correct. So there, you can turn that on or off in the thermostat, but most of the time, if you say 6 o'clock, I want it warm at 6 o'clock, it could start at 4:30 or 5 or 5:30, however long it takes to get from point A to point B. The thermostat learns that, so it knows how long it's going to take. So if you want it warm at 6, it'll be warm at 6. You don't have to go, gee, I wonder how long it's going to take to heat up. I better start it half an hour early, right? It does that for you. It figures that all out. So if you say, I want it warm at 6, it'll be warm at 6.
Fabulous. And I think a lot of us are really looking for ways to make our home a little bit healthier, especially if you have kids. And this is a really great way, to reduce allergens. I know I look like that lady in the picture 5 days out of the week. My allergies are insane, and it really does help to reduce that dust, reduce those allergens that are floating around from the forced air. Obviously, when you're blowing forced air throughout the house, you're going to be picking things up, moving things around, and kind of encouraging those allergens to spread. And then, Scott, can you kind of talk about relative humidity and why it's important for some people?
Yeah, the relative humidity is very important if you're using LVT, if you're using laminate, if you're using hardwood or engineered wood, stuff that expands and contracts when it gets when it's very humid, it expands. And in the wintertime, if you have forced air heat, it dries out and contracts. So you have a flooring that's doing this sometimes in the summer, in the winter, summer, winter, expands, contracts. And that's not because of the heat per se, it's because of the relative humidity in the room. That's the one thing that people don't think about is I'm going to put a hardwood floor in and I'm going to put electric floor heating. And people say, oh, no, you don't want to do that because the heat will dry it out. The heat is not going to dry it out. What dries it out is the forced air system in that house pushing out dry air. And that's what's drying the system up. So when you're installing a floor that has a humidity requirement, like if you buy hardwood or that sort of stuff, and they say must be in a relative humidity band between 30 and 60%, you're going to be responsible for keeping that product within 30 to 60%. That's up to you, either using humidification in the wintertime or dehumidification in the summertime. And the heat under it coming from the floor heat is negligible. It's not going to impact it. It's the relative humidity in the room that makes that product expand and contract.
Yes, absolutely. And the system has a pretty great ease of installation. This is not an especially proprietary or difficult system, speaking generally, to install. And Scott, I know you've done a lot of these, so can you kind of tell us some of the basics when installing a floor heating system?
Yeah, we've been in this business for a long time. We've been around for quite a while, longer than most of our competitors. And we know there's more than one way to install floor heating. Some companies will tell you, you need a membrane for this and you need a membrane to put wire in. Well, that membrane and wire is fine for some jobs, but you don't need it for every job. And the membrane costs extra. So why spend that extra amount that you don't need to spend when you want to heat your floor? So a membrane like this in the blue that you see down here is good to isolate for isolation from the tile from the subfloor. If the subfloor moves, it's good for tile in that case. But if you're heating laminate or if you're heating hardwood or anything like that, you don't need this membrane. This membrane, we don't care if the subfloor gets maybe a little crack in it, because that flooring is going to be there no matter if there's a little tiny crack in the subfloor or not. So it's a much more carefree installation if you're going to be using laminate or stuff like that. So not every floor requires that membrane. Sometimes if you're going to just use tile on a really solid floor that you don't have to worry about, it's got a real narrow floor joist, very, very strong. You don't need the membrane. You can just use the cable and strips and save yourself hundreds of dollars of installation costs. So it's very easy to do. You don't need to be an engineer to put it in. You don't have to worry about, what valve am I going to turn on? What do I need another pump or anything like that? All you need to do is you just need to get electricity up to that room, hopefully a dedicated line, and then you hook it to the floor and then you're good to go. And sometimes it depends on what your local code says, if you need to have an electrician do any of that, but we strongly suggest that you have an electrician put your dedicated circuit in for the floor, and also that he or she wires it to the thermostat, that circuit, and wires the product to the thermostat. Other than that, in most states, you can do it all yourself. So it's very difficult to have a DIY installation for hot water. Very, very difficult to do that. So this is really good. There's a bunch of different ways to heat the floor, and we're going to be talking about that in a little bit.
Yeah, so can you kind of tell us what the quickest installation would be?
This one. This is the easiest one to do because there's no thin set, there's no self-leveling. All there is this product on top of thermal sheet. You put the thermal sheet down on the floor and you put it loose. You don't have to attach it because this is Environ. Environ doesn't attach to anything and nothing attaches to it. It floats. So you can put the thermal sheet down in a loose manner, just like a brick wall. You do it in a brick pattern, and then you lay this product on top of it. You run it over to the wall. You run the power up to the wall to the thermostat, and then you put the flooring on top of it. Very, very easy to do. This product is good for carpet, stretch-in carpet, not carpet squares, but stretch-in carpet in the United States. It's good for laminate and good for engineered wood. And for LVT, you wouldn't be using this.
Yes, and I don't think we ever said the name of this product. This is Environ. So these are our cut and turn rolls that are really ideal for situations like Scott just said, floating floors, engineered wood, carpet, things like that, this is going to be a really good option for you. And then we do have what we would consider the best universal installation, which would be utilizing temp zone systems embedded within a self-leveling cement. So can you kind of tell us, Scott, why that is?
Yeah, because what you're building is a heated subfloor for any type of flooring that goes on top of it. You're just creating this, you're attaching it to the wood subfloor, or if you're in the basement, you're attaching it to the concrete slab very, very well using the thermal sheet. And then you are putting this on top of that, and you're adhering this product, the green mesh, very, very well to the subfloor, either the thermal sheet or the wood. Because if you don't, self-leveling is very dense. Everything will try to float. So you don't want this electric electric floor heating to float. You want it to stay down. And most LVTs require that you have a half-inch space between the wire and the flooring. So that's where you would put in a half-inch layer of this self-leveling, and that's going to give you a nice flat floor. That is a requirement for many LVT floors. It's also going to give you the half-inch spacing to keep the wire away from that floor. And it's going to make it so if you decide to lift that LVT and go, hey, you know what? I want to replace this with laminate. You just lift the LVT, you put laminate in. If you say, you know what, let's tile this. I'm tired of this. Let's tile it. You lift it all up, and then you just back butter the tile and tile on top of this. So what you're doing is you're creating a heated subfloor that you can use all kinds of flooring products on top of.
Yeah, easy as that. All right, and I know that we did receive a question ahead of time regarding installing on a slab. So can you kind of tell us, Scott, how that would work?
Yeah, there's a difference between on a slab and in a slab. So that's one of the questions that we're going to ask you. We have a couple slides here. So let's go ahead and take a look at those. This slide is when you're pouring a new slab and you want to put the electric heating inside of it. So what you do, this is especially prevalent for people that are doing polished concrete floors, which means they're just taking this concrete slab and they're polishing it up. They're making it look real pretty, and then that's going to be the final flooring. Well, the only way to heat that is to put the heating system inside of it. So this is what you do if you're going to have a new slab and if you're going to be doing polished warm floors. This is the way you're going to do it. You've got that compressed crushed rock, then you've got polystyrene insulation, a 2-inch layer or more, whatever your local code requires or permits. Then what you would do is you would have, you can do it a couple ways. You take this product and you put it on rebar and you prop the rebar up into the middle of the pour. So if you've got a 6-inch slab or a 4-inch slab or whatever that thickness of slab is, you're going to prop it up on the rebar so the cable's right in the middle of it, because that allows it the heat to reach the top. So that's what you see here, a top layer and a bottom layer, but really this can be poured all in place. You don't need to do it in 2 steps. You can do it in 2 steps if you want, but it's really hard for big, like if you're doing a big space, it's hard to say, okay, let's pour a level of 2 inches, then we'll drop the stuff down on it, then pour it. You don't want to do that in a big hurried up job with concrete. Those guys never have time for you. So what you want to do is you want to get it set up, get the wire propped up in the middle of the pour, and then pour concrete over and it flows through, and that ends up in the middle because you've put it on concrete chairs or steps or on debris or something that's going to prop that cable up halfway in the slab. So that's how you would do a polished concrete floor. Now, the next one we're going to look at is how you can heat on top of a concrete slab, but do it in a faster acting method, because you can see this layer here is going to be much thinner that we're going to heat. It's not going to be 6 inches of concrete or 4 inches of concrete. It's going to be about a half an inch on top of the concrete. So what you want to do here is you want to have that concrete slab, then you want to put the thermal sheet on top of it, because that's going to isolate the cable from the slab. The slab is going to try to suck that heat down, trying to warm the slab first. We don't want to warm the slab in this case. We just want to heat the half-inch or so above the slab and none of the slab. That allows you to use less power. It allows you to heat it quicker. So that's what you do here. You'd put the slab, the thermal sheet, attach it to the slab with a modified thin set. Then you would put the electric floor heating system on top of that. Then you would put modified thin set on top and set the tiles into that. And that way you're heating a much thinner portion. So those are the two different ways to heat in a concrete slab or on top of a concrete slab. This is why
Awesome.
we'll ask you when you call us and we're going to ask you, are you pouring a new slab? Do you want the heat in it? Or are you going over a slab? Because there's two different products.
Yes, definitely important to clarify. And then I'm not seeing any other questions right now. If anything comes up, feel free to ask us. But we'll do a little housekeeping here. Our next webinar is going to be Thursday, May 9th, again, 1 o'clock Central Time right here on Zoom. And it's going to be a step-by-step guide to heated luxury vinyl floors. So please join us for that. We're going to give you a ton of really good, helpful information. And we do also offer daily trainings. Again, these are on Zoom as well, usually hosted by me or by Scott. Occasionally, you'll get some other of our technical experts or sales team. And we just basically will chat with you a little bit about a certain topic. And then if you have any questions, you can ask away, even if it's off topic. Just feel free to kind of use these as almost like office hours. And then, of course, we are offering 25% off on select towel warmers for the month of April. So visit our website to learn a little bit more about that promotion. And once this webinar is over, we'll send an email asking about your experience and looking for some feedback. We'd love to hear comments, suggestions, especially suggestions on topics that you would like to see a webinar on in the future. Just be sure to let us know. We want to make sure that we are giving you the information and the help that you are looking for. And of course, if there's any questions, if you want to quote, if you want to just chat about your project and see if this is a good fit for you, reach out to us. We are always available. You can visit our website 24/7. You can email us. You can give us a call. We would be more than happy to chat with you. And that's all I have. So unless you have anything to add, Scott, I think we are good to go. Thank you so much for joining us. Until next time, stay warm
And be radiant. Bye, everybody.